I'm going to make a client-server based Java horse racing game. It was suggested by Kevin Robb, so thanks for that. And the game's called Grand Digital, which is a play on Grand National. So I'm going to start by drawing a UML class diagram of what we're going to build. Got a server on the left and a client on the right. The main Grand Digital Server class will schedule races, and then the data model for the race is down here. We've got a race object which will control running the race, and then it will return the winner to the server, and the horse object which will represent individual horses. The user interface will display the horses running as the race updates, and then when the race is finished, the socket will send a UDP multicast packet over to however many clients are listening. I'll use UDP multicast because that doesn't care whether there's anybody listening or not, but it will just broadcast the message to however many clients are there, if any. So the client will have a player object that will keep track of the balance that the player has, and a user interface which will allow the player to bet on the horses, wait for the result to come in, and then update the player balance. So that's the general design for the game. So now let's build it. Okay, so thanks to the UML diagram, I've got a pretty good idea what I'm going to build. So I'm going to go ahead and add all the classes. Okay, so I've added the two packages, the server and the client, and I've added Grand Digital Server into the server. I've then made 3 sub packages which I've done the same for the client and the server. I've got a comms package which contains the 2 sockets, a data package which contains the race and the horse on the server side and the player on the client side, and a user interface package. I've called it GD Server UI and GD Client UI. I've done a similar thing to socket just so that I don't get confused when I look at like socket or UI, I know which side I'm on. Okay, so now let's implement the classes. Right, so I'm going to start with horse. Okay, so the horse is very straightforward. It's just got a distance property, and when we reset the horse back to the beginning of the race, we just set the distance to 0, and we've got a get distance method which the main server class can use to see if the horse has won. The one method which is interesting is going to be the run method. Now this, we're going to want to add some distance, but we're going to want to add some variability. Now what I think I'm going to do, I think if I just pick a random number for each of the horses, it may end up balancing out and they'll all be approximately as the race will be too close. So what I'm going to do is when we reset the horse, I'm going to generate a random handicap value for the horse, and that's going to be added on to the distance for each time step. So this is going to be a sort of variable to say whether the horse is having a good race or not. Now when we run, I'm going to step the horse. I'm going to generate a random, we may play around with these later, but I'll generate a random number between 25 and, no, let's say between 90 and 100, so it's significantly more than the handicap value. So a random number between 1 and 10 plus 90. And that'll be the step, and then we'll make the race. We'll definitely play around with the length of the race, but we'll say we'll make it 10,000 distance. So the distance for the horse in this time step, we'll add step, and then we'll add the handicap value. So I think that that's pretty much it for the horse class. Now I'll create the race. So we want the race object to have a reset and a race method that will return the winner. Okay, so I'll add those methods first. I'm going to add a variable for the length of the race. Now I said 10,000, so this can be private because it's only required in race, which will call the horses to make them run, and then it will compare the distance to, if the distance is over this distance, that horse wins. I suppose it's possible that we may have 2 horses win. Seems we're using an integer, but we'll see how that turns out. And the race is going to contain a list of horses. Now I think we'll start off, we'll have 5 horses in a race. So I define that as a variable because we may need it, we may want to change it later. Number of runners. And when we construct a race, we'll just do this once at the start of the program. We'll just create a list of horses with the length number of runners. So the reset method's very straightforward. We're just going to reset every horse. Okay, so for the race method, we want this to be a blocking method, and we want it to basically keep calling the horses, the horse method to the run method of the horse, and then we'll check to see if there's a winner. If there's a winner, we'll return from the race method. If not, we'll pause for a moment and then run again. So I'm going to add a method to check for a winner. This method will return null if there's no winner, and it will return the winner if any of the horses has won. To do this, we can just say if horse get distance is greater than the length of the race length. And if it is, we'll return horse. Now the first horse is going to have a slight advantage because it's going to be considered first. So if 2 horses win at the same time, the first horse is going to win, but we'll see how that works out. None of the horses win, we'll return null. And we can say while get winner equals null, or we'll say horse winner equals get winner, while winner equals null, and we'll run that again at the end. So we'll have a small delay. I'll put in a variable for it. 25 milliseconds again. I'm going to see how this works out, and after the delay we'll just move all the horses. And return winner. So this method is going to block for the whole race. Okay, so that's the horse and the race class finished now. Now I'm going to go on to the main server class. So the main server class is going to be the central class. It's going to have the race, the user interface and the socket. I think I'm going to keep it quite simple. I'm just going to schedule a new race to start every minute, say, and regardless of whether there's any clients listening or not, the race will just go ahead. So we want the main server class to call race once a minute, and we also need to tell the socket that the race has started and tell the socket that the race has ended with the winner. So let's do this. So we'll just do it straight from the constructor. We'll exit if the user interface gets closed, but we'll just do a while true loop, and we'll do a system exit to close everything down if the user closes a window. So while true, okay, so I might change this later, but I've defined a race interval of 60 seconds. So we're stuck in a while true loop here, which is only going to exit if the user closes the user interface. We're going to wait until the time now is 60 seconds after the previously recorded time now. And just one more thing to do is when we do get out of that loop, just reset time now, and this loop is just going to sleep for 1 second to save overloading the processor with considering this. So we'll start a new race every 60 seconds, we'll notify the socket at the start of the race, run the race and get the winner, and we'll notify the socket at the end of the race. We just need to make the user interface and implement the socket. Okay, so now we're going to build the user interface for the server. Okay, so I've set the frame into grid layout, so we'll have labels, one for each horse, going down the screen. At the minute I'm just using labels, but later we'll change it to some sort of horse animation. And I'm storing the labels in a hash map along with their respective horse. And I've added an update labels method that will loop through the runners of the race. I've also added this race get runners method, and it will update the label for now with the text value of the distance of the horse. Now one other thing I'm going to do is I'm going to make a race listener interface, and I'm going to add the race listener interface because we're going to want to call this update label as the race goes on. So let's do that. Okay, so the idea of that then is that this user interface is a race listener with the method defined in race listener notify race progress, and it's added the race object, and if it's not nil as the race progresses, that listener gets notified of the race progress. So hopefully now we should see the race, the numbers increasing in the user interface. I forgot to construct the user interface and set the race listener in race. So GD server UI. Okay, I think we should have some sort of progress thing to tell us whether the race is running or not. I suppose we'll see when we improve the graphics. I'm going to add a status label to this user interface, and I'll put that in the race listener method. Okay, so I've added a label at the bottom of all the horse labels, which is a status label. Added one to the grid layout so it fits, and then I've added a method notify status, which will set that label, and then in the main class, as I count down to the start of the race, so I'm now getting a time to race number of seconds, so that's the time now minus the time that we saved, and then I'm going to say race starts in however many seconds. So let's see if that works. Okay, it's counting up. That'll be something easy to fix. Let's wait for 60 seconds. Okay, that didn't work at all. It got to about 50 and then went to -7, I think. So time to race. The problem here is that date.getSeconds was comparing seconds past a minute instead of seconds past a common time. So I changed it to date.getTime. Okay, and they're off, and we have a winner, but we actually have 3 that have crossed 10,000, so we're definitely going to have to fiddle with this a bit, but we've got this going again, so we're going to have to stop. We're going to have to make them run at much different speeds, and we need to get this counted down rather than up. So that first change is very easy. We can just say race starts in race interval minus time to race seconds. And I think for the sake of testing, the race seemed to go really quite quickly, so I think I'll run a race every 10 seconds. So let's just check that those things have worked. So race starts in 10, 5, 4, 3, 2, 1, and they're off. And now 4 of them have crossed 10,000. So we really need to play around with the race parameters, and the race is too fast, I think. and it didn't reset. Okay. Okay, so this seems to be good now. We seem to be getting one clear winner. I think I've changed the method just to be the step value is just random number between 0 and 100. That seems to do the trick. I'm not sure whether the handicap is making much difference, but we'll leave it because it seems good. We have horse 1 won this race. And then horse 3 won that race. So that seems good. One little change I'm going to make is I want a delay of 10 seconds between every race. So at the moment, depending on how long the race takes, we're delaying just the remainder of the 10 seconds. So the races are starting every 10 seconds instead of having a 10-second delay between them. So I'll just tweak that. So that's in the main server class. So we'll do, when we've got the winner, we'll just save the time there. Okay, so now the only thing we've got for the server to do is the socket and also the graphics, but we'll do the graphics at the end. So we're back to 10 seconds. Horse 5 won. And horse 1 won. Okay. Okay, so for the socket, we're going to have a notify race start and notify the race end with the winner, and we're just going to send an S character over for the race start and the number of the winner for the notify race end. Okay, so let's implement that. Okay, so I've implemented this. I'm going to have to give the horses a number so we can identify them here. I could have passed the index in here, but it'd be better to give the horses a number. So I've constructed the socket here. If anything goes wrong, I'm just going to exit completely. It shouldn't go wrong, but if it does, I'll exit with an error code. I'm going to send on this internet address, which is a multicast address. So we construct the socket there. If on the race start, we'll send an S, and when the race ends, we'll send the winner's number, which we'll have that as a string. And this is a send method, so we can send whatever we want. So I'll just add the winner number. So when we construct a horse, we'll do it with the name of a horse. I think I'll make it a name of a horse. And for the name of the horse, we'll just call it 1, 2, 3, 4, so string value of I. And in the socket, I'm just going to do a system output line. The best way to test the socket will be to implement the other side, but for now, in the send method, I'll just say what's being sent. System output line, server sending S. So let's test this. So race starts in 10 seconds. We want, when the race starts, for say server sending S, and then whichever horse wins, server sending the number of the horse. No, it didn't happen because I don't think I've set up the socket. So construct the socket there, and then where we had the comments in here, socket notify race start, and socket notify race end of the winner. So apart from the graphics, I think that's the server done. So let's test. Server selling S, and the winner is horse 1. Race again in 5, 4, 3, 2, 1, and the winner is number 3. It's numbered from 0. So that's the server done. We'll implement the client now, and then we'll improve the graphics later. Okay, so now onto the client. I think the first thing I'll implement is a socket so that we can test that the message is coming through. So let's start by implementing the socket and the main client class. Okay, so I've made the client socket, which is just going to construct the socket, it joins the multicast group, and then it's just going to loop around and it's going to loop around receiving bytes as they come through. So I'm going to run up a client and just make sure that the socket's working, and then we'll tie this together with the rest of the client. So I'll run up the server, and again, a multicast socket, it's just going to send. It doesn't care if there's a client listening or not, so this is just going to send the messages. But now we'll run up a client. And there you go, client received S. If we look at the console for the server, server sending 3, client received 3. If we look at the server, but we're looking at the console of the client received 2, that was the winning horse. So the client is receiving, and the cool thing about multicast is if I now run another client, this client's received 3, and this client also received 3. So we've got a server now on 2 clients, and so it's like a multiplayer system. So we'll just shut everything down now, and then we'll carry on implementing the client. Now before we had a race listener that was listening for changes in race, and we did that for the UI so that the UI could update when the race changed. We're gonna do a similar thing here. So we'll have a player listener, and this user interface will listen to changes in player. We'll also have a socket listener, and this user interface and the player will listen to changes in the socket. So they'll get notified when a horse wins a race or when the race starts, and then we'll do the relevant things in the user interface and the player when the race starts, and when a horse wins the race. So let's do that. Okay, so the socket listener gets notified when the race starts and notified when there's a winner, and the player listener will get notified when the player changes. Now we'll go to the socket and we'll give it a listener. Actually, we'll make this the listener for socket, the main class, and then we'll distribute the messages as required. The user interface will be the only player listener. Okay, so now I'm going to implement the player. So the player has a balance. When we construct the player, we'll give him his initial balance. So we'll set this as this is the money that he's got to bet with, or the tokens that he's got to bet with. So I'm going to give the player a method to place bet. We'll give it the horse index. So when he places a bet, current balance reduces by 1 token, and we'll remember the horse index. Bet horse index. So remember which horse he bet on. And then we'll have another method we'd notify winner with horse index, and then if horse index is the horse that he bet on, we'll increase his balance by the number of horses in the race. So the odds are 5 to 1 really. And whenever the balance changes, we'll notify the listener. let's change number of runners to static there so that we can access it from the player. So I think that's player around about finished. So now we'll develop the user interface next. Now that's going to be similar to the user interface of the user interface of the server so far. We'll have five buttons where we can click to bet on a race, and when we press those clicks we'll notify the player. We disable the buttons. Also, when the socket has a race start message coming in, we'll disable the buttons in the user interface. So I'm going to start by just taking all of the code out of the server user interface, cut and paste it into the client, and then change it to be the way I want it. Okay, so I'm passing the player to the client. I've still got a status label, and this time I've got buttons, and they're indexed by integer. So I'm using the same layout as I did in the server, and for each of the runners I'm adding a button and putting it in the hash map indexed by integer. And then adding the status label, I'm setting this client to shut down if the window gets closed, and I'm setting the size and location and setting it visible. Then I've got methods notify race start and notify race end. When the race starts, the status label is set to say race in progress and the buttons are all disabled. When the race ends, the status label is set to say place bets and the buttons are enabled. Then when the player changes, we're updating the balance. We'll say place bets balance equals player.get balance. I didn't actually implement that method, so I'll just implement it now. It's called current balance. So I'll just change it to get balance. Okay, so I still need to add listeners to the buttons to place the bet in player, but first I'll just glue everything together. So I'll go into the main client class. Now I've constructed the player, it wants the listener, but the user interface is the listener to player. So I'll just change the way this works, and instead of passing the listener as a constructor, we'll just make it a setter. We'll have an empty player constructor. Just need to change the main method to now construct this class and run. So there we've got 5 buttons. We don't have anything written in the button, and here's a status label down here, but the server's not running. So what we need to do is label these buttons and add listeners to them to call place bets on the player. I'll also make that a bit smaller, there's no need for that to be so tall. Okay, we're adding 1 onto I because we want to present to the user bet on horse 1, 2, 3, 4, 5. We don't want them to see that we're indexing from 0 because it's more intuitive for the user to see the numbers 1 to 5. And we'll set an action command in the button. So there we are setting the action command, which is a string, to string value of I without adding 1, so that's going to be the horse index from 0 to 4. And when the button is pressed, we're going to play a place bet, the integer value of the action command. So if I just trace that through, to be honest, I can't remember what I haven't done now, but I think we're close to having it working. So let's run up a client, bet on horse 1, place a bet. Let's run up a server. When the race starts, we want the buttons to get disabled. I suppose I should display in the status bar which button we pressed on. They're not being disabled. This label isn't showing up at all, so quite a bit not done. Okay, so I'll take it one step at a time. So when the user clicks on a button, we'll set the status label to say which horse we bet on. Status label set text, bet on horse. And we'll get that from player. So in player, I'm gonna, the bet horse index, I'm gonna make a getter for that. I'm gonna initialize bet horse index to -1, and if we get notified of a winner when bet horse index is not -1, so if it is -1, we're going to do this. If it's not -1, we'll do this. If it is -1, we'll ignore this winner because we don't want to award a win to the player if he's not even bet on a horse. Now when we place the bet, we're going to reduce the balance by 1, so from the user interface I'm going to disable the buttons at that point. So I'll just make a method to disable or enable all the buttons. And so the user will present the +1, so 1 to 5 instead of 0 to 4, and enable buttons. So when we place a bet, we say which horse we bet on. I suppose we could also, we'll always say, but in fact, let's have a second status button for balance. So we'll add 1 onto the grid layout. We'll have a second label for balance. So we've added the balance label, and we've added a method update balance, and whenever anything happens, we'll update the balance. So run the server, run the client, bet on horse 1, nothing's appearing down here, so something's wrong there. Let me fix that. Right, I haven't added the listener to the buttons, so bet button, add action listener, this, and that goes along with the action command. So I'll run the server, I'll just keep the server running for now. I'll run the client, bet on horse 1, balance is 99, the race is running, but we don't know about that. Client sees one. So when the race is running, we want to notify this. If there's a current bet on, we will well, we'll just wait till we find out who wins. So we need to implement the socket listener. That is going to be this. It has the methods. In the socket, we just need to call the socket listener when we get the race start and win in on the socket. So if s equals s, that should probably be a variable, but I'll just leave it like that. Listener notify race start. Else it's a win, so listener notify winner s. And then the main class, which implements this socket listener, pass that into the socket, and this will get notified on race start. This will get notified on winner. So UI notify race start and UI notify race end. Player notify winner. This is the value of winner. Okay, so I think it needs a bit of tweaking, but I think that's basically it. So let's give it a try. Run the server and run the client. Bet on horse 1, we bet on horse 1, race in progress, and horse 4 won. So our balance is now 99. Let's bet on horse 2. Balance is now 98. Horse 5 won. Let's bet on horse 3. I'm going to keep testing until we win. Horse 2 won. 97. Bet on horse 4. I'm also testing every button as I go through. Horse 2 won. Bet on horse 5. Race in progress. Horse 3 won. This next race I'm not going to bet, so we want the balance to stay at 95. Race in progress, and I can't bet now, so that's what I wanted. Balance is still 95 now. I'm going to continuously bet on horse 1 until horse 1 wins. So balance is now 94. If horse 1 wins, I'll get 5. Horse 2 won. Now I could do something to the server to make sure horse 1 wins, but I'll have a bit of patience. Right, horse 1 won. So I had a balance of 91 before, I've now got 96. So I'm not doing very well at this because I'm already 5 tokens or £5 or $5 down. And I've won again with horse 1. So I'm back up to 100. Now, of course, all this is running through a socket and a multicast socket at that. So there's no need for these clients to be on the same machine. So there I've run, let's run 5 clients. There's no need for these clients to be on the same machine, and so it's fun for all the family really. We've got 5 clients. Everyone has a balance of, every time horse 1 wins, this guy who last bet on horse 1 is making an extra £5, but it's not costing anything to bet, so that needs fixing. So that's an unexpected bug, but let's bet on 1, 2, 3, 4, 5. Oh, I bet on 4 for that one, but let's see who wins. 5 won, so they all lost. 1, 2, 3, 4, 5. And 3 won. Now let me just check that what I just said about this one getting awarded 5 is right. It's 1-1, so he's up to 108. Um, 98, 103, and 98. 2-1, so he's up to 103. Right, so if you don't bet, you are essentially betting on the horse that you last bet for free. So let's just shut everything down, and when we get notified of a winner in player, we're going to set bet horse index back to -1. And I'll just test that again by running the server and 5 clients in the same way as I just did. So there's the server, and we have 1, 2, 3, 4, 5 clients. Okay, so everyone's balance is 100. We bet on 1, 2, 3, 4, 5. Everyone's balance is now 99. The race starts, and horse 5 wins. So he's up to 104. Everyone else is on 99. I'm not going to touch it again. The next race, nobody's going to bet. You just want to make sure that nobody wins if nobody's paid to bet. 2 wins and 2 is still on 99. So that's now working pretty well, and all I think we've got left to do is make it a bit more fun, is to have some animated horses moving across the screen. That probably also give us a good idea about whether our run algorithm is, well, algorithm's a bit rich, but it's the random number picker to whether the race is exciting or not, and if it's not, we'll do something to fix that a bit. Okay, so I've made these 3 quite ridiculous pictures of horses with the jockey on it. This is why you need a graphic artist if you're going to make games. But I'll just show the principle of animation. So what I'm going to do is I've saved these as 3 separate images. I'm going to put these, draw them on the panel, and I'm going to alternate between the 3 different images just to give the impression of the horse's legs moving. I know it's ridiculous. If you want to follow along, you can. I'll make this source code available so you can put your own images in place if you can do better, and you can even make more frames of animation rather than 3, but I've just done 3 to start with. So let's modify the user interface class to use these horses and animate them moving across the screen. Okay, so if we have another look at the server UI, we had the status text box at the bottom and 5 labels. We're going to remove those labels, put the thing into border layout, and we'll set the status label at the bottom, the border layout south, and then we'll just add a panel in the center, and we'll implement the draw method in that panel to draw the horses. Okay, so this is going to take some trial and error, so I'll speed through and explain it all at the end. Okay, so what I've done so far is I've put the thing into border layout and put the status bar down there. I've loaded and I've taken away the labels altogether. So if we look at this server UI, the labels are gone and it's just replaced with one race panel. This this method here, update labels, we'll rename this to update graphics, I think, because we're not updating the labels anymore because there are no labels. I think actually update labels wasn't a very good name, so we rename that method to update graphics. Just repaint, notify race progress, will update graphics, and the race panel just loads the image and it just paints it on the screen. So I'm going to load 3 images and I'm going to paint them relative to the panel size and relative to how far the horses are through the race. So again, we'll whiz through this and I'll explain it later. Okay, so what I've done here so far is I've worked out the lane height is 1/5, or it's the height of the panel divided by the number of runners. That's 1/5 of the panel. The lane width is the width of the panel minus the width of one of the images, because the horse is going to start off over on the left and it's going to move to the right. When the right hand side of the image touches the right hand side of the panel, that's the total width of the lanes that the horses are running in. So we start off with y0, and for each runner we want to work out the x position. So that is the lane width multiplied by a value from 0 to 1. So I've added a get race complete method to the horse, and that's giving us the proportion of the race complete by taking distance and dividing it by the total race length, which was 10,000. I changed this to be a static so we could access it outside. So now I'm expecting one horse image to slide across the screen, but the image will be the wrong size, I think. So there's her 5 horses, and race starts in 3, 2, 1, go. Okay, so not updated. Okay, so I need to debug that. Let's see what's happening. Okay, so I think what's happening is the value being cast to an int is just coming through as either 0 or 1. So because in horse this distance is an integer, so we need to cast these to doubles to make sure we're not just rounding it down to 0 or 1, rounding it to 0 or 1. This is actually almost the right size. 3, 2, 1, and they're off. I'm not going to bother with the size. I think that's pretty good, but the winner is, well, we'll have another couple of races. Actually, I do want to set the size of the image to be smaller. It's quite close, the race. I might have to tweak that a bit, but I'll make the image a bit smaller. Other than that, and use the 3 animated images. Other than that, we're nearly finished. Okay, so I'll get the images the right size. I'll do that first. Okay, that was completely simple. Just had to put the width and the height of the image. We're keeping the image the standard width of the image, but the height we just set it to lane height. So it's a very simple change just on the draw image method. So next I want to alternate between the 3 different images, and I think this is going to look ridiculous animation, but it should be fun. Okay, so actually we want the animation step. We'll run it from the update. So let's have because we don't want the horses to move their legs when they're not running. So public void step animation. We'll add a method step animation. We'll make just a counter. Counter. When step animation happens, we'll add one onto counter. And the anim step can be counter mod 3. So anim step's going to be 0, 1 or 2, and then depending on its value we'll draw either image 1, 2 or 3 according to the anim step. So the step animation, we're going to call that from the server. Actually, where is it? Server UI update graphics. So panel step animation. So that update graphics is being called from race progress, and that's only going to happen when the horses are moving. So that, I think, is everything. So we have our 5 horses, their legs aren't moving. 4, 3, 2, 1. They're moving ridiculously, but it looks alright. And horse 4, 1. That's socket sent 3. So that's our game. So let's run up a client and let's have a gamble. Need to wait for the race to finish before I can bet. And I'm going to bet on horse 3. So balance is 99. And it won 104. Brilliant. So if you want to download the source code for this game, I'll make it available and I'll put in the comments below where you can get that from. If you'd like to play around with this, there's a couple of jobs that you could do to it. I mean, you could make the graphics better. You could, if you can draw a better picture of a horse, you could change it to have more horses in the race, more or less, depending on what you want. And you can run up clients and play the game. Maybe a more advanced change would be to make the horses, give them odds. So for example, one horse is 2 to 1 and it's 50% chance of winning. Another horse could be 10 to 1 and like just a 10% chance of winning, and that could be a pretty interesting change to make. Okay, I'll run up another few clients to check the sort of multiplayer function of it. So the clients can't bet now because the race is in progress. We should be able to resize the window and the horses will shrink because it's all been done relative to the panel size. Okay, so let's bet on 1, 3 and 5. Bet on horse 1, bet on horse 3, bet on horse 5. And thereafter, and horse 3 is going to win. Yes, horse 3 won. There's one final test to try. I've moved the source code onto another laptop here, and if I can show you what we have here, this is a separate laptop, and we can bet over here, and the race happens on my main machine. and it works. And I actually won because I bet on horse 1 and horse 1 won. So there we can see we can play it multiplayer on different machines because of the UDP multicast. So thanks for watching. If you'd like to download the source code, I'll leave a link in the comments below. So if you've learned something from the video, give it a like, and if you'd like to see more videos like this, then subscribe to my channel. Thanks for watching.